In this video, I'm going to solve this question. For the regression model yi equal to beta 1 plus beta 2 xi plus ui, the fitted regression equation is this. So we have yi hat equal to b1 plus b2 xi. In each of the cases below, find the new fitted regression equation yi star hat and express it in terms of yi hat. And these are the two cases that are given to us. Now, this question might seem a bit odd at this stage. So let's do one thing. Let's do this in a step-by-step manner. So first of all, I'm going to work with the first case. So case number 1. The case number 1 is that we add a constant lambda to each x value. Okay, so this is the first case that we have. So now let me make a partition over here. So over here we are going to talk about two types of model. And now on the left hand side, I'm going to write all the details related to the original model. By the original model, I mean the model that's already given to us in the question, that is this one. Okay. And on the right hand side, I'm going to write all the details related to the new model. The new model is the model that we will get once we incorporate this case. So let's see what all information we have about the original model. So we know that the population model as given in the question is yi equal to beta 1 plus beta 2 xi plus ui. Okay, so this is the model that's already given to us. In this model, the dependent variable is y and the independent variable is x. So the dependent variable is y and the independent variable is x. We are also given the fitted regression equation. So the fitted regression equation is yi hat equal to b1 plus b2 xi, where b1 is obviously the estimator of beta 1. So b1 is the estimator of beta 1 and b2 is the estimator of beta 2. Okay, so this is the information that's given to us. Now we are given that we are adding a constant lambda to each x value. Let's understand what do we mean by this. So see, your dependent variable is y and your independent variable is x to start with. So let's write some values of y over here. Let's say that there are three values, 100, 200 and 300. Similarly, let's write three values for x and let's say the values are 2, 7 and 3. So let's say this is the x and y data that we have. Now if I add a constant lambda to each x value, so let me create a new column over here and let's say that we have new x written in this column. Okay, so new x is 2 plus lambda, 7 plus lambda and 3 plus lambda. Okay, because it's written over here that we are adding a constant lambda to each x value. So the new x is going to be this. Now let me also put a notation for the new x over here. So let's say the new x is x star. So as you can see, what is the relationship between x star and x? Well, x star is equal to x plus lambda. So this is first thing that you need to keep in mind. Now let's write some information about the new regression model. So in the new regression model, the dependent variable is going to be, so the dependent variable over here is, note that in the case number 1, we are not changing the y variable over here. So this column is still valid. The only thing that we are doing is we are adding lambda to each x value. So now for the case number 1, this column is not valid. The only valid columns are this column and this column. Okay, so your dependent variable is y because we are not changing it, so it is the same dependent variable that you have over here. Just to differentiate the notations between the new and the original, if you want, you can also write it as y star, but that will not change the meaning. The y star and y in this case are going to be the same, and in this case the independent variable is going to be So the independent variable for the new regression model. Now see, the independent variable for the new regression model cannot be x because we have added lambda to each x value. So now we are going to work with this column over here. So the independent variable has to be x star, okay, which is actually equal to x plus lambda. So for the dependent variable, it doesn't matter whether you write y or y star. Either way, both of them are one and the same thing. If you want, you can write y. If you want, you can write y star, but that will not make a difference. But in the independent variable, you have to be careful. You cannot write x over here. You have to make sure that you write x star, right? So basically with this information, how can I write the population model? So if I want to write the population model now, I can write that it is yi star. I could have also written yi over here equal to beta 1 star plus beta 2 star xi star plus ui star. So the difference between the new and the original regression model is that for the dependent variable over here, I have yi. For the dependent variable over here, I can write yi or yi star. It doesn't matter. These are just different notations, but they mean the same thing. The population parameters over here in the original model are beta 1 and beta 2. Now for the new regression model, I cannot use the same notations. So I'm just using a variation of these notations. So instead of beta 1, I'm using beta 1 star. And instead of beta 2, I'm using beta 2 star. The independent variable over here is xi star, and this is something you have to be really careful about because xi star is your normal xi plus lambda, and this ui star is just the population error term for the new regression model. Okay, so this is what we have. And now if I try to write the fitted regression equation, so in this particular case with all of these notations, the fitted regression equation will look something like yi star hat equal to b1 star plus b2 star xi star. Okay, so this is how the fitted equation is going to look like, where b1 star is actually the estimator of beta 1 star. So this is the estimator of beta 1 star, and b2 star is the estimator of beta 2 star. Okay, so this is the information that we have, and this is how the new fitted regression equation, so I should write new over here. This is how the new fitted regression equation is going to look like. So this is the structure of the new fitted regression equation. Now it's mentioned in the question that we have to find the new fitted regression equation and we have to express it in terms of yi hat. So I have to express this new fitted regression equation, that is I have to express this thing over here in terms of yi hat. Let's see how can I do that. So basically I need to find some sort of relationship between these two. So to achieve that, we are going to find the relationship between b1 star and b1 and b2 star and b2 and xi star and xi. So if you are able to find a relationship between these three and these three, then automatically we will have some relationship between yi star hat and yi hat. So now the problem statement is to find these three relationships, and out of these three relationships we do not have to worry about the relationship between xi star and xi because we have already found that. So out of the three relationships we have already figured out the third one. So now we just need to figure out the relationship between b1 star and b1 and b2 star and b2. So let's see how can we do that. So for that I'm going to write some formulas over here. First let's try to find the relationship between b2 star and b2. Now over here b2 is equal to summation of xi minus x bar yi minus y bar divided by summation of xi minus x bar whole square. So in this particular case, your dependent variable is y, your independent variable is x. So the formula to find b2 is equal to this. On the other hand, in the new regression model, the dependent variable is y or y star. It does not matter what you write over here. Okay, it will not make a difference. And the independent variable is x star. You cannot write x over here because x star and x are two different things now. So in this particular case, b2 is equal to summation of, now instead of xi, we have xi star everywhere. So this is going to be summation of xi star minus x star bar multiplied with yi star minus y star bar divided by summation of xi star minus x star bar whole square. So these are the two formulas that we have, and in fact I should have written b2 star over here and not b2. Now let's see how can we find the relationship between these two. Some of the things that I know by now are that xi star can be written as xi plus lambda. Okay, that's the first thing that we know. Second thing, that instead of yi star, if I want, I can also write yi over here, right? Because I told you that y star and y are one and the same thing. So in this bracket, okay, over here, it does not matter whether I write y star minus y star bar, or if I want, I can also write yi minus y bar over here, right? Instead of this xi star, if I want, I can write xi plus lambda. Similarly, instead of this xi star, if I want, I can write xi plus lambda. We have already established this relationship. Now let's discuss what is it that we can write instead of this x star bar. Well, it's quite simple to figure that out. Note that what is the mean of x? So you cannot see this data over here, but the values that are written over here are 2, 7 and 3. So if you find the mean of x, the mean of x is going to be 2 plus 7 plus 3 divided by 3. So this is going to be 4. Okay, so x bar, which is the mean of x, is equal to 4. Now if you try to find the mean of x star, that is, if you try to find x star bar, you will find that this is equal to 4 plus lambda. If you want, you can try this on your own. You can add these three values and divide it by 3. You will find that the mean of x star is 4 plus lambda. Basically, if you increase each value of x by lambda, even the mean gets increased by lambda. Okay, so from here we can figure out the relationship between x star bar and x bar. The relationship between these two is that x star bar is equal to x bar plus lambda. So as you can see over here, x bar is 4 and x star bar is 4 plus lambda. So I can write, instead of this, I can actually write x bar plus lambda. Similarly, instead of this, I can write x bar plus lambda. Now let's do the substitution and see what is it that we get over here. So let me create some space for that. So if I do the substitution over here, I'll get that b2 star is equal to summation. Instead of xi star, I'm going to write xi plus lambda, minus, instead of x star bar, I'm going to write x bar plus lambda. And instead of y star minus y star bar, if I want, I can write it as yi minus y bar. And this is divided by summation of xi plus lambda minus x bar plus lambda whole square. Now this can be written as summation xi plus lambda minus x bar minus lambda, because there was a common minus sign over here, multiplied with yi minus y bar divided by summation of xi plus lambda minus x bar minus lambda whole square. Now this and this gets cancelled, this and this gets cancelled. So we get that b2 star is just equal to summation of xi minus x bar yi minus y bar divided by summation of xi minus x bar whole square, which is nothing but the same formula that's written over here. So basically b2 and b2 star are going to be same. So in the new regression model, even after adding the constant lambda to each x value, we get that nothing changes about b2. Okay, so whatever b2 you would have got in the original regression model, you're getting the same thing over here. So these two are equal, right? So this is the first thing that we have got, that b2 star is equal to b2. Now the last thing that we are left with is that we need to figure out the relationship between b1 star and b1. So again, let me create some space over here. So if you recall, b1 was equal to y bar minus b2 x bar, and b1 star was equal to y star bar minus b2 star x star bar. The reason being, in the original model, so this is for the original model. In the original model, the dependent variable was y. So the first term is the mean of the dependent variable, and the independent variable was x. So over here you have the mean of the independent variable, and this is your slope coefficient. In the new model, you have b1 star. This is the mean of the dependent variable of the new model. Well, I told you in the new model, because we are not changing anything about y, if you want, you can also write y bar over here. It will mean one and the same thing because the y column has not changed in this particular case. B2 star, we just saw that there is no difference between B2 star and B2. So instead of this, I can also write B2 over here. And we have already established the relationship between x star bar and x bar. We know that x star bar is equal to x bar plus lambda. So I can put this relationship over here. Instead of this, I can put x bar plus lambda. So B1 star is actually equal to y bar minus B2 multiplied with x bar plus lambda. This implies that B1 star is equal to y bar minus B2 x bar minus B2 lambda. Note that this thing that you have got over here is nothing but B1. So this B1 star is actually equal to B1 minus B2 lambda. Okay, so this is the relationship between B1 star and B1. So now we are done finding all the relationships that we wanted to find to reach the final answer. So this is what we have got till now, and our motive is that we have to write the new fitted regression equation in the terms of yi hat. That means we have to write yi star hat in terms of yi hat. And now this is a very simple thing. So this is what your yi star hat is. So we can write that yi hat star is equal to b1 star. Instead of b1 star, we can write b1 minus b2 lambda plus, instead of b2 star, I can just write b2. Instead of xi star, we can write xi plus lambda, and this becomes b1 minus b2 lambda plus b2 xi plus b2 lambda. This and this gets cancelled, and we get y hat star is equal to b1 plus b2 xi, which is exactly the same thing that's written over here. This implies that yi hat star is just equal to your yi hat. Okay, so this is what they wanted us to find for the first case. Now we have to do the same type of exercise for the second case. The only difference is that in the second case, we are going to change the dependent variable and we are not changing the independent variable. Now see, we have the same type of story over here. It's just that now we are adding a constant mu to each y value. So to understand this, let's take a look at the data. So let's say this is how the data looks like. We will have y. So let's take 100, 200, 300 over here. And let's say x values are 2, 7 and 3. Now we are not changing the x variable, but we are changing the y variable. So the new y variable, which I can also call y star, is actually equal to 100 plus mu, 200 plus mu and 300 plus mu. Note that this is mu over here and this is u over here. This is population error, and mu is just some random constant that we are adding to each value of y. Now once again, what's the relationship between y star and y? Well, y star is just equal to y plus mu. That's the first thing. And if you want to find the relationship between the mean of y star and the mean of y, then even that's going to be simple. The mean of y, which is y bar, is 100 plus 200 plus 300 divided by 3. So that's just going to be 200. And if you try to find the mean of y star, that means y star bar, you will see that the mean will come out to be 200 plus mu. So basically, if you increase each value of y by mu, then even the mean value will get increased by mu. Okay, this is something that you can check on your own. However, this is quite intuitive as well. So the relationship between the y bar and y star bar is that y star bar is equal to y bar plus mu. So these are the two relationships that we already know now. So in the new model, the dependent variable is now, so dependent variable is yi star. So this is your dependent variable. You cannot have y as your dependent variable because now you have transformed y by adding mu to each value. So now this is the data that we are working with. So your dependent variable has changed and the independent variable has not changed. So it's completely your wish if you want to write xi star or xi, because in this case, it's not going to matter. Okay, so if you want to keep consistency in the notations, then you can write xi star, but even if you write xi, that's going to be fine. So in this case, the population model is going to be yi star is equal to beta 1 star plus beta 2 star xi star plus ui star. So yi star is the new dependent variable that we have got. I'm writing beta 1 star and beta 2 star because these are just some variations of these notations, because we cannot have the same notations. Xi star is your independent variable. It doesn't matter whether you write xi star or xi because there are no changes to the x variable. And ui star is just the population error term of this new model. Now in this case, if I want to write the fitted regression equation, then it will be yi star hat is equal to b1 star plus b2 star xi star. Okay, this is star over here, where similarly b1 star is the estimator of beta 1 star. So b1 star is the estimator of beta 1 star and b2 star is the estimator of beta 2 star. Now once again we have to do the same thing. We have to find the relationship between this and this. So we have to write yi star hat in terms of yi hat. To do that, we are going to find the relationship between b1 star and b1, b2 star and b2, and xi star and xi. Well, actually there is no need to find the relationship between xi star and xi because we already know that these two are one and the same thing. Okay, because there are no changes to the independent variable over here. So we already know that these two are same. So now our purpose is that we have to find the relationship between b1 star and b1 and b2 star and b2. So let's write the formulas over here. Over here, b2 is equal to summation of xi minus x bar, yi minus y bar divided by summation of xi minus x bar whole square. Over here, b2 star is going to be equal to summation of, well, see, it doesn't matter whether I write xi star or xi. So let me just write xi minus x bar over here because either way we are going to substitute as we did in the first case. Then the dependent variable is yi star. So it's yi star minus y star bar divided by summation of xi minus x bar whole square. Now we already know the relationship between yi star and yi. So instead of this yi star using this particular relationship, I can just put yi plus mu. And instead of y star bar, I can just put y bar plus mu. Okay, so I can put y bar plus mu over here. Let's do this substitution and let's see what is it that we get. So let me create some space over here. So from here we get that b2 star is equal to summation of xi minus x bar. Instead of y star, I'm writing yi plus mu. Instead of y star bar, I'm writing y bar plus mu. And because there is a negative sign over here, so this will become minus y bar minus mu. Okay, because there is a negative sign over here. Divided by summation of xi minus x bar whole square. Now I can cancel this mu and mu, so we get that b2 star is equal to summation of xi minus x bar yi minus y bar divided by summation of xi minus x bar whole square, which is exactly the same thing as b2. So even in this case, b2 star is equal to b2. This is the same thing that we got in the first case as well. Now we have to find the relationship between b1 star and b1. So let's create some more space over here. So b1 is equal to y bar minus b2 x bar and b1 star is equal to y star bar minus b2 star x star bar. Note that it doesn't matter whether I write x star bar or x bar because both of them are one and the same thing. So I can just write x bar over here. We just saw that b2 star and b2 are same. So instead of this, I can just write b2. And we already know the relationship between y star bar and y bar. Instead of y star bar, I can just write y bar plus mu. So b1 star is actually equal to, this is star over here, y bar plus mu minus b2 x bar, and this can be written as y bar minus b2 x bar plus mu, where this is nothing but b1. So this implies that b1 star is equal to b1 plus mu. right? So this is the relationship between b1 star and b1. With all this information, now we are all set to take a look at the final expression that we need to find. So this is the information that we have found till now. This is your original model and this is the original fitted regression equation. This is your new model. In this new model, if you want, you can also write xi instead of xi star because we are not changing the independent variable. This is your new fitted regression equation, and as written in the question, we have to express the new fitted regression equation in terms of yi hat. So we have to express yi star hat in terms of yi hat, and it's going to be really simple now. We just have to use these relationships that we have found. So we can write that yi hat star is equal to, instead of b1 star, we can just write b1 plus mu. Instead of b2 star, we can write b2. And instead of xi star, we can just write xi. So this is yi star hat is equal to b1 plus b2 xi plus mu. This is nothing but yi hat. So this implies yi star hat is equal to yi hat plus mu. Okay, so this is the relationship between your yi hat star and your yi hat, and this is what we had to do. So this is all for this question.